Good afternoon, everyone. Thank you for joining us today for our webinar, Driving Down Pollution, State Opportunities for Low Carbon Fuel Standards. I'm Jeremy Tarr, and I'm the director of our state policy program at Clean Air Task Force. CATF, our state advocacy leverages deep technical and policy expertise that we're known for, and we provide timely, fact-based education, analysis, and insights to help advance climate and clean energy solutions across the country. We work with vital stakeholders like yourselves, including state legislatures, governor's offices, executive agencies, local communities, and others to really help achieve their economic, environmental, and public health goals through climate action. This is our third webinar in a series that we're doing this year on various salient state policy topics. Our first two webinars earlier this year covered clean electricity standards and meeting load growth with clean firm power. Before we dive into today's important topic, I have just a couple of housekeeping items. One, the webinar is being recorded, and the recording will be available on our website afterwards. Second, we welcome your questions. We'll have a Q&A portion at the end of the webinar. If you'd like to ask a question, just go ahead and submit it into the chat. You can do that anytime throughout the webinar, and we will see it and address it in the Q&A. Today, our CATF experts are going to guide us through a conversation about low carbon fuel standards, what they are, how they work, why they're vital to driving down emissions from the transportation sector. The transportation sector accounts for nearly a third of U.S. greenhouse gas emissions, making it a significant driver of harmful air pollution. Electrification is a powerful tool for decarbonizing transportation, but there's a full suite of policy options that are on the table to tackle the complex and wide-reaching challenge of decarbonizing all of the subsectors in our transportation sector. So LCFS's low carbon fuel standards deploy a market-based approach to incentivize the development and use of lower carbon transportation fuels. There are several states, including California, Oregon, and Washington, that already have implemented LCFS programs. Others are currently exploring policy approaches, which is why we thought this topic would be a timely webinar. At CATF, we believe that state-based LCFS programs are key to reducing transportation-related pollution and advancing low-carbon fuel technologies. This is a pretty dynamic, complex policy, but our experts are here to take us through both the big picture and the key details of LCFS programs at the state level. So you're going to hear from Jonathan Lewis, who is the director of CATF's Transportation Decarbonization Program, and Rachel Starr, who is the Senior U.S. Policy Manager for Hydrogen and Transportation Decarbonization at Clean Air Task Force. Thank you again for being here today. As a reminder, put your questions in the chat, and I'll turn things over to Jonathan to get us started.
Thanks, Jeremy, and welcome, everyone, and thanks for joining us today. I'm going to get us started with some background in the transportation sector and the diverse energy needs that it presents. So the sector as a whole emits around 8 billion tons of carbon dioxide equivalent per year, which is about 20% of total global emissions. It also emits vast quantities of conventional pollutants, including particulate matter, sulfur dioxide, and a variety of carcinogenic toxins. Electrification is absolutely essential for eliminating greenhouse gas emissions and conventional pollution from the transportation sector. CATF's Transportation Decarbonization Program is pushing to eliminate transportation sector emissions by mid-century, and that goal is only achievable if the uptake of battery electric vehicles is wildly successful. But even if it is wildly successful, a battery-based strategy is not in itself sufficient. The reason is that as much as 1/3 of the sector's emissions come from heavy-duty vehicles, it will be difficult or maybe even impossible to electrify. So you can see from the second column here, trucks emit around 2 billion tons of greenhouse gas per year globally. A lot of those trucks can potentially run on batteries, and some of the freight they carry can potentially be shifted to either less emitting modes of transportation like rail or marine. But our analysis indicates that there will be persistent demand for energy carriers that can support long-distance truck routes, short refueling times, and very high runtime/asset utilization rates. There's interest in hydrogen fuel trucks, for example, because hydrogen can outperform batteries on each of those metrics. The aviation sector emits another billion tons annually. Batteries can only play a niche role at best in the aviation sector. The sector needs huge volumes of energy-dense, low-carbon fuels. CATF analysis has shown that even if airlines could use the entire global supply of biofuels going forward, that's all the biofuels produced everywhere in the world, that would only meet about half of the industry's projected future energy demand. So in addition to getting its hands on all of the available biofuel that's actually low carbon, the industry will also have to use tens of billions of gallons of climate neutral synthetic fuel and eventually straight hydrogen in order to serve its market. Lastly, the maritime sector also emits around 1 billion tons per year. It's likely to get outcompeted for biofuels by the aviation sector, given the aviation sector's smaller option set and a higher willingness to pay. So the maritime sector needs to find alternative climate-compatible, energy-dense fuels that can be scaled massively. Ammonia appears to be the most viable option at this point, but significant work needs to be done to minimize ammonia's carbon intensity, develop systems for using it safely, and building out new distribution and fuel bunkering networks. So with that in context, if we could stay on slide 2 for a moment. So with that context in mind, let's move to the crux of today's discussion. A core tenet of CATF's transportation work is that flexible, technology-agnostic performance standards that require gradual reductions in carbon intensity, or CI, of the transportation fuel mix, which includes electricity, can and should play a critical role in addressing and eventually eliminating emissions from the diverse transportation sector, including from the 3 segments of the sector detailed in this slide. Slide 3, please. So this kind of policy, a clean fuel standard or CFS, has been implemented by California, Oregon, Washington, British Columbia, and Canada nationally. And bills and other draft versions of the policy are being developed for the US federal government and for other states and provinces, something that Rachel Starr will discuss in more detail later. California pioneered the policy more than 15 years ago when it implemented its low carbon fuel standard. I've excerpted some text from the California Air Resources Board that does a pretty good job describing the multiple ways a well-designed and well-implemented clean fuel standard can work. The text is both explanatory and aspirational, so it's worth taking a second to parse it. The first part, that clean fuel standards are a key part of a comprehensive set of programs, is important because while clean fuel standard is a potentially powerful tool, particularly due to its ability to establish long-term priorities and expectations for the market, the policy works best in conjunction with other programs, especially more targeted programs that separately support the commercialization or cost reduction of key emerging technologies. The second part of this excerpt underlines that clean fuel standard policies can and should be useful at reducing both greenhouse gases and non-GHG pollutants. The third and fourth part illustrate that a CFS has twin goals. First, to establish real-time requirements that transportation fuels get cleaner and cleaner on a year-over-year basis, but also to send clear market signals that energy and vehicle producers can rely on to make both near-term and long-term investment decisions. Slide 4, please, or the next slide. So a clean fuel standard works by indirectly subsidizing low-carbon alternative fuels and energy carriers, for example, electricity, hydrogen-based fuels, certain biofuels, by awarding tradable credits to producers of fuels that beat the carbon intensity target. It increases the cost of carbon-intensive fuel by requiring producers of those fuels to buy enough credits to offset their exceedance of the carbon intensity target for each annual compliance period. The policy hinges on a determination of a fuel's full life cycle carbon intensity, or the amount of greenhouse gas that's emitted per unit of energy delivered. A fuel's carbon intensity is usually described in terms of grams of CO2e per megajoule or per MMBTU. That value is then typically adjusted to account for the efficiency with which the fuel can be converted into traction by the vehicle. For example, an electric motor is more efficient at turning a megajoule of electricity into forward movement than an internal combustion engine is at turning a megajoule of gasoline into similar movement. The centrality of carbon intensity is both a strength and a weakness of the clean fuel standard approach. It's a strength because it's a measurable metric that's tied to broader societal and policy goals, and it can be used to compare and differentiate different energy carriers. It's a weakness because our ability to assess carbon intensity is far from perfect, especially for energy carriers like biofuels that are produced via processes that absorb and emit carbon in ways that can't be directly measured because those processes occur over large landscapes. These types of emissions have to be modeled rather than measured, and modeling creates uncertainty, confusion, and unfortunately, opportunities for mischief and fraud. Next slide, please. So here's what a clean fuel standard looks like when it's laid out over a 40-year period. Each vertical bar represents the carbon intensity standard for a given year. As you can see, the annual CI requirements in this particular version of a clean fuel standard decrease gradually to approximately zero by 2050. This trajectory that's illustrated here happens to come from a national bill that CATF has been working on with the congressional office. The blue bars for 2011 through 2023 track the targets set by California for its LCFS. The magenta bars would establish a pathway to zero carbon transportation energy by 2050. If you look at the slope, you can see that it's not perfectly linear. It has sort of a reverse S-curve to it. That trajectory changes somewhat over the period. It's relatively gradual during the 2020s. It gets steeper through the 2030s when electricity and electrification is projected to capture a major share of the transportation energy demand. And then it flattens a little bit in the 2040s to accommodate the challenge of decarbonizing the residual hardest to abate vehicles on the market, the vehicles that are going to be the most difficult or perhaps impossible to electrify. Next slide, please. So clean fuel standards create a market with tradable credits. If a fuel provider sells fuel that has a carbon intensity that's less than that year's CI standard, it earns credits. If another fuel provider sells fuel that exceeds the annual standard, it generates a deficit, and it needs to buy credits from cleaner fuel providers in order to come into compliance. Next slide, please. The two bar charts here illustrate how that crediting system would work in two example years, 2026 and 2038. The horizontal line in the two charts corresponds to the annual standards in the chart I displayed a minute ago. If we could flip back 2 slides, that would be great. So the 2020, this is a bit of an eye chart, but the 2026 chart, you can see the 2026 line corresponds to the chart that is around 80 grams of CO2e per megajoule. And the 2038 line is set at, it corresponds to that bar, which is tops out at 30 grams of CO2e per megajoule. So if we could go back to, yes, thanks. In 2026, when the CI standard is 80 grams in this hypothetical CFS, fuel providers that sell gasoline and diesel into the market will generate deficits, depicted here by this, this red increment. To comply with the clean fuel standard, those fuel providers will have to buy credits from providers who are selling other cleaner fuels into the market, represented here by biofuels and electricity supplies with higher and lower carbon intensities. So that's the other 4 bars. The light blue arrows represent the number of credits that a specific volume of each of those types of fuels would generate when sold into the market. 12 years later, looking now at the bar chart on the right-hand side, if fuel providers were still marketing these same 5 energy carriers, only the low-carbon electricity, the bar to the farthest to the right, would generate any credits. The other pathways would all generate deficits, which in practical terms would mean that they would be getting phased out of the market. Next slide, please. So how is this working out in the original clean fuel standard, California's low carbon fuel standard? California worked through a series of amendments last year in 2024. One of those included a 2045 carbon intensity target that comes to about 10 grams of carbon dioxide equivalent per megajoule, which you can see in the left side of the chart. So it's what California committed to last year is something that CATF is urging all developers of clean fuel standards to do, which is to set a long-term goal that gets us close to zero, that clarifies the obligations for industry over a period that's long enough for them to make the sufficient investments in fuels that will generate credits throughout that period. This chart on the right shows the number of credits that different energy carriers have earned under the program over the last decade or so. So as you can see from all the various shades of blue, compliance with the California Low Carbon Fuel Standard is still heavily tied to biofuels. That's what is it, 4 or 5 different types of biofuels that account for those shades of blue. But electricity is making inroads. Electricity is depicted here as the yellow portions of those bars. Key questions going forward for CATF at least is whether and to what extent the low carbon fuel standard is supporting electrification. Are those yellow bars going to grow? Is the CFS, is the low carbon fuel standard pushing that growth, or is it essentially codifying developments that are happening elsewhere in the market for other reasons? That's a key question. The other key question that we're keeping an eye on and trying to understand how to manipulate is whether and to what extent the low carbon fuel standard supports the deployment of fuels that aren't even registering on this chart yet. So fuels like hydrogen or hydrogen-based fuels. If it hasn't broken into the market yet, does a low carbon fuel standard provide the incentive and the structure for the producers of those fuels to gain a toehold? We think the answer is yes, but that may depend on policy design elements that would need to be built into the California policy or expanded within the California policy and written into clean fuel standards that are under development in other states or at national levels. So with that background, I am going to turn it over to my colleague, Rachel Starr.
Thanks, Jonathan. Could you go to the next slide? Great, thank you. So as CATF works with policymakers, environmental groups, and other stakeholders throughout the US on ways to design, implement, and improve clean fuel standards, we've identified 4 policy elements that we see as hallmarks of a strong clean fuel standard. And those 4 are outlined here. I'll go through all of them. So a CFS should clearly require that a fuel's CI or carbon intensity be reduced to near zero by mid-century, utilize the best and most comprehensive life cycle greenhouse gas analyses for determining fuels' carbon intensities, include safeguards to prevent over-reliance on fuels that have hard-to-model carbon intensities, particularly fuels that are produced through processes that can result in significant indirect greenhouse gas emissions, and apply to fuels used throughout the transportation sector, not limited just to on-road fuels. So starting with the trajectory to zero criteria, the transportation sector cannot fully decarbonize by mid-century without access to energy carriers that have carbon intensities that are zero or near zero. That means lots of clean electricity, as well as low carbon liquid and gaseous transportation fuels will be needed to power heavy-duty, long-haul vehicles like planes, marine ships, and some trucks. Near zero 2050 carbon intensity targets are the best policy mechanism for requiring large-scale development and deployment of climate-compatible fuels. Such standards would complement power sector initiatives to reduce the carbon intensity of electricity by sending a clear demand signal to the power sector from the transportation sector. This target also offers assurance to historically overburdened and underserved communities that a full shift to an emissions-free transportation sector everywhere is the policy's ultimate objective. Further, it will increase the policy's likelihood of success by sending an explicit and long-term signal about requirements of energy carriers sold into the transportation sector. The near zero carbon intensity target focuses attention and investment on fuels and technologies that are compatible with the zero emissions transportation sector, while also clarifying the near and midterm roles that can be filled by fuels that offer some level of emissions reduction, but cannot ultimately achieve extremely low carbon intensities. An ideal clean fuel standard establishes a full set of annual targets that decline to zero or near zero by mid-century, but a shorter-term policy that charts an obvious trajectory toward an appropriately ambitious mid-century target can still put a state or other jurisdiction on the right path. The next criteria is a robust life cycle greenhouse gas analysis. Clean fuel standards revolve around point estimates of fuels' carbon intensities. A comparison between a fuel's carbon intensity and the annual carbon intensity requirement dictates whether and to what extent that fuel generates deficits that need to be rectified or credits that can be sold. Comparisons between the carbon intensities of different fuel options will shape compliance strategies, which in turn will drive investment decisions in multiple sectors like agriculture, refining, vehicle manufacturing, and energy retailing. Accordingly, regulators must ensure that CI determinations are made using tools that incorporate the best data, the most defensible assumptions, and the strongest, most up-to-date, and most comprehensive tools for measuring the attributional and consequential effects of policy-induced fuel production and consumption. Distinguishing between strong and weak LCAs can be difficult due to the inherent complexity in these tools and the substantial uncertainty around key assumptions and processes. These challenges are most acute in the context of biofuels, especially with regard to issues like indirect land use change, or ILUC. Strong life cycle analyses assess and include emissions from ILUC, which are difficult to quantify. Notwithstanding the uncertainty surrounding ILUC emissions, we know for certain that ILUC emissions associated with most conventional biofuels are greater than zero. So a clean fuel standard that ignores or significantly discounts those emissions essentially puts its finger on the scale in favor of land-intensive biofuels and does so at the expense of other alternative fuels. The third policy element is safeguards against public health threats and over-reliance on unsustainable feedstocks. Robust and reliable life cycle analyses are essential to a functional clean fuel standard, but LCAs alone are not sufficient. Even the best LCAs struggle to capture market-mediated impacts of increased fuel production, especially emissions from indirect land use changes that occur as global agriculture markets reestablish supply and demand equilibria following new policy-induced demand for bioenergy crops. Regulators therefore need tools or safeguards to manage the extent to which regulated entities can base compliance on the sale of fuels with CI scores that have a high degree of uncertainty. This ensures that fuel producers don't comply by relying on fuels that pose new or additional threats to public health, or depend on feedstocks that cannot be sustainably sourced. Limits on a given fuel type could be adjusted if, for instance, the fuel producer demonstrates that production of additional volumes of fuel does not require additional land use. The need for safeguards is most acute for biofuels, especially renewable diesel and biodiesel made from vegetable oil, but other transportation fuels may also pose sustainability concerns that need to be managed. For example, if renewable electricity is diverted from the grid to a hypothetical electrolyzer, an LCA may indicate that the carbon intensity of the resulting hydrogen is very low, but the LCA might not be capable of adequately assessing the climate impact outside of the transportation sector if a fossil fuel-fired power station increases production to make up for the diverted renewable electricity. And the last attribute that I'll mention here is the multi-sector coverage for a clean fuel standard. So a clean fuel standard should apply to fuels, including electricity, used in different segments of the transportation sector, starting with on and off-road fuels, aviation fuels, and marine fuels, since transportation subsectors do not exist independently of one another when it comes to energy use. For example, vegetable oil can be used to make sustainable aviation fuel, renewable diesel, and biomethanol, but the supply of sustainably produced vegetable oil is limited. So using it to make SAF will reduce the supply of renewable diesel available to long-haul trucks and the supply of biomethanol available to marine ships. Meanwhile, a transition to battery-powered light-duty vehicles and the subsequent reduction in demand for gasoline-ethanol blends could increase ethanol's availability as a feedstock for SAF production. The best way to manage these interactions is to apply the same or similar carbon intensity requirements to on and off-road fuels, aviation fuels, and marine fuels, and let market forces like willingness to pay sort out the most efficient uses of feedstocks and fuels for achieving the necessary CI reductions in each subsector. full sector coverage is a more important attribute for a national CFS than it is for state policies, especially with respect to marine fuel consumption, which is low or non-existent in some states. Aviation fuel, however, needs to be addressed in some way by all jurisdictions that are considering a CFS, given the aviation sector's significant presence in every state and the looming competition between producers of road fuels and aviation fuels for climate-compatible biogenic feedstocks. Next slide, please. So taking a closer look at some existing state-level clean fuel standards, so far there are only 4 states with enacted clean fuel standards: California, as mentioned before, Washington, Oregon, and New Mexico. And there are several other states that have introduced legislation or have otherwise explored pursuing a CFS. And as outlined on this slide, California is the only state that meets the trajectory to near zero attribute so far. Further, there are currently no state clean fuel standards that mandate coverage beyond the on-road sector. As previously mentioned, certain sectors might have varying relevance in a given state, but the most robust clean fuel standard would cover all sectors. At the moment, all 4 clean fuel standards include aviation on an opt-in basis, meaning qualifying clean aviation fuel producers can choose to generate credits under the CFS, but they are not obligated to meet annual carbon intensity targets. Oregon and Washington also include marine fuels on a limited opt-in basis, but again, do not obligate them. The opt-in option is certainly better than nothing, but it's not as strong as obligating a given subsector. This is especially important for states like California that have several major ports and airports. A decade and a half of experience with clean fuel standards has convinced CATF that a CFS can be a powerful tool for eliminating transportation sector emissions, but existing CFS approaches, best exemplified by the California Low Carbon Fuel Standard, also show that structural and targeted fixes are needed to help accelerate and/or ensure the deployment of the most health and climate beneficial technologies. Ultimately, a comprehensive federal level clean fuel standard is probably the best option for efficiently reshaping national scale fuel markets that serve wide-ranging industries, especially aviation and marine. But state and regional clean fuel standards can play an important role in driving innovation and investment in clean transportation energy systems, at least until there's an opportunity to enact such a policy at the federal level and perhaps indefinitely. Next slide, please. CATF has engaged deeply with state CFS programs, both at the legislation and implementation stages. In California, which has the longest running clean fuel standard in the country, CATF collaborated closely with the California Air Resources Board, also known as CARB, environmental groups, and other stakeholders to submit multiple comments on proposed changes to California's LCFS program. Most recently, CARB was considering modifications, including strengthening the program's 2030 targets, obligating aviation fuels, extending the targets beyond 2030, and addressing the oversupply of credits and suppressed credit prices. CATF focused our advocacy in support of obligating aviation fuels and credit oversupply issues via limiting use of crop oil-based fuels. CARB decided not to obligate aviation fuels at this time, even for intrastate use, citing potential conflict with federal authority. However, to address the credit oversupply and suppressed prices, CARB did decide to limit the eligibility of fuels made from soy, canola, and sunflower oils to no more than 20% of fuel sold in the state, which is the current market share for those oils, based in part on CATF's recommendations, which we discussed in detail with CARB staff and board members. These fuels are currently flooding the California market, so capping their eligibility should help correct the oversupply of credits and the suppressed price issues that the LCFS is facing right now. In New Mexico, CATF submitted comments on the draft Clean Fuel Standard rule and met with the New Mexico Environment Department, the implementing agency, afterwards to discuss our feedback with them. We continue to follow the updates posted on the Clean Transportation Fuel Program webpage as the New Mexico Environment Department moves through the rulemaking process. Next slide, please. So as I mentioned, there are a handful of other states that have introduced clean fuel standards or have otherwise explored the possibility of one, as shown on the map and in this table. I'm not going to go through the whole table right now, but it serves as a reference for where clean fuel standard efforts stand in different states that have had activity in this space in the past. CATF has also engaged with some of these states through local experts and advocacy groups. For example, we've talked with Clean Fuels Michigan, a Michigan-based group that brings together stakeholders from across the industry to advance clean transportation in the state, and other organizations to provide technical assistance and discuss possible changes to a future iteration of legislation as they gather stakeholder input. In all of these engagements, we focus on the 4 key characteristics I outlined earlier while examining state-specific issues on a case-by-case basis to ensure maximum climate benefit and decarbonization of the transportation sector. And with that, I'll turn it back to you, Jeremy. Thank you.
Thank you, Rachel. Okay, so we have plenty of time for Q&A, questions and answers. We already have quite a few coming in, and I'll just take them one at a time. So this first one is about the relationship between low carbon fuel standards and electrification. To what extent is LCFS a distraction from electrification? How much investment and planning is required to bring low carbon fuels into the mix? And would that time, energy, and resources be better spent focusing on electrification? Jonathan, let's over to you on that one.
Yeah, thank you. It's a good question, and it's one that we've conducted some research in. The upshot of the research is it's a difficult question to answer with any real specificity, but the takeaway seems to be that a low carbon fuel standard is complementary to electrification and can be supportive based on design features of your particular clean fuel standard. As I mentioned earlier, electrification, we have virtually no hope of eliminating emissions from the transportation sector or even cutting them deeply without electrification succeeding wildly. So as the question implies, a policy at the very worst can't get in the way of electrification. We don't think a clean fuel standard does. In fact, we think over time it'll bolster and support investments in electrification, both on the supply side and the vehicle side. The second point I want to make is that if the goal is to eliminate emissions or cut emissions deeply from the transportation sector, and as much as a third of those emissions currently are coming from vehicles that will be difficult or impossible to electrify, we need other tools. Electrification is badly needed, but so are other energy carriers that can move planes, marine ships, and heavy-duty trucks, or trucks that have a use case that does not allow for long refueling times. Those 3 sectors emit billions of tons of CO2 around the world. So we need to promote innovation and deployment of technologies that can serve them sort of at least in the near term and the midterm, and probably for in perpetuity in the case at least of aircraft and transoceanic marine vessels. So that's why we think we also need a market-based policy that puts electricity and other energy carriers on a similar competitive footing, and electrification should do very well in that context. But there are other energy carriers that there should be a market for them as well, and we think that this policy will help sort out which one of those non-electricity energy carriers are most closely consistent with our decarbonization goals.
You mentioned that state clean fuel standards are like complementary policies with other types of transportation policies. Could you talk about what a LCFS does, reducing the carbon intensity of fuels over time? in relation to other familiar state level transportation policies like the Advanced Clean Trucks rule.
Yeah.
They mutually exclusive? If you have one, do you need the other, or do they serve different complementary purposes?
Yeah, it's a great question. We think they're mutually beneficial. To use the example that you just laid out, the Advanced Clean Truck Rule, which is one of the California policies that other states can adopt via the California Waiver Authority, assuming that that waiver authority isn't taken away either through congressional action or EPA regulatory action. So the way that the two policies can interact is that they both, by having both of them implemented at the same time, it creates a level of confidence in both ends of the clean transportation value chain. So if you are the producer of clean energy carriers, say hydrogen for long haul trucks, or for hydrogen as an input into synthetic sustainable aviation fuel. A clean fuel standard lets you know that there is going to be a market for your low carbon fuels for over the long term. You know, in the case of a policy that runs through mid-century, at least to 2050, you are going to know how your fuel is going to compete in that market, whether it's generating deficits or credits based on the way it's produced and its carbon intensity. However, you don't necessarily know that you will have you don't know what your customer base is going to look like, because the LCFS impacts the energy supply of that equation. If you have something like Advanced Clean Truck, which requires the industry to deploy a higher percentage of zero emission vehicles each year over time, there is a growing set of customers that will be purchasing your, to use this example, hydrogen fuel for long haul trucks. And so the existence of those two policies simultaneously will provide hydrogen fuel producers with extra confidence. On the other side, if you're a truck producer and you're selling hydrogen fuel cell trucks into the market, your customers are going to want to know that they're going to be able to fuel their trucks. The existence of a clean fuel standard on the energy supply side of this equation will give them confidence that there's this policy that is pulling clean fuel into the market, incentivizing the production of fuel, which will result in the build out of a fuel supply network over time. And so by pursuing both policies together, you sort of create conditions of investment confidence across the full value chain.
So knowing that there's going to be an increased purchase of low carbon trucks tells fuel producers that there are going to be vehicles to use a low carbon fuel. And if there's increased clean fuels, then if you're buying these trucks, you know you're going to have fuel to run the trucks on.
Exactly.
And so the question about electrification, so it sounds like electricity is considered a fuel as in the vernacular that you're using. And with clean fuel standards, they incentivize electrification of transportation, right?
That's right. That's right. Electricity, like other fuels, can be assessed a carbon intensity, it's based on the way it's produced, of course. Electricity that's produced by a coal-fired power plant has higher carbon intensity than electricity produced at a solar farm or a nuclear power plant. And so it encourages, just as it encourages a reduced use of high carbon fuels like gasoline or diesel, it incentivizes the increased use of low carbon electricity production.
Mm. Okay, this next question is about aviation and federal preemption. So how is it possible or legal to make aviation fuels deficit generators in a state CFS programs. I think this is in response to the aviation slide you put up. Isn't there a federal preemption issue with regulating aviation fuels at the state level?
I can start with this, and Rachel, if you want to jump in, please do. So that the federal regulation, that the federal law that California was most focused on when it considered this question was the Aviation Deregulation Act, and that act preempts any state law that would affect the rates, costs of aviation routes around the country, trans-state, cross-state aviation routes. California determined that a clean fuel standard might run afoul of that requirement, and decided it didn't want to sort of take on that litigation risk when it was trying to move through this large amendment package. There's, among lawyers who've looked at that, there's a strong range of opinions on whether or not that was the correct legal determination. We think there's a strong case that low carbon fuel standard, specifically California's low carbon fuel standard, doesn't run afoul of the Aviation Deregulation Act. And we and others are sort of revisiting that legal interpretation to understand if, going forward, California might be able to expand its LCFS so that aviation fuel is covered. It's important for California, it's important for other states, it's important for a federal bill for reasons that Rachel just described. These policies work best if all of these different segments of the transportation sector are under one sort of regulatorily defined market, so that we know that we can use market forces to ensure that different fuels that are limited in their supply are going to the segment that needs them the most or can make the most climate beneficial use of them.
Related question about federal dynamics. What's the value of pursuing a state-based LCFS given the potential for a federal LCFS? So over the past number of years, there's been discussions. You indicated that earlier about having a federal clean fuel standard. What's the relationship between state clean fuel standards in the context of potential federal clean fuel standards, which there was potential over the past couple of years, but now going forward, what's your assessment of potential for federal clean fuel standard in the near term, and what does that mean for the value of doing state level LCFSs?
I can start on this one, but Jonathan, feel free to jump in. So I think I'll maybe start with the last part of your question. The potential for a federal clean fuel standard is probably limited during this Congress and maybe even during this administration, but CATF is still working on our idea and workshopping it with stakeholders and modifying it as we go and collecting input, and we're trying to be ready for whatever the time is right to socialize that more widely and hopefully have it go somewhere further than it already has in Congress. So probably limited outlook for the time being, but it doesn't mean that we can't work on it in the meantime. And I think the value of state clean fuel standards, or even sort of coordinating regionally, is that places like California, where there's been the longest running clean fuel standard, they've been sort of leading the way in this effort around the country, and they are setting an example. They're learning lessons. They're doing a lot of things that everybody else can learn from. For better or for worse, if you're California, but everybody else can sort of watch as they go and learn a little bit, and hopefully take the best parts of what they're doing and apply it in their own state. I think there's like a little bit of a risk of each state adopting their own clean fuel standard and having it be different than their neighbors. And that becomes a problem when you think about, airplanes cross multiple state lines, or, same with cars, and, companies are based in multiple states or have, multiple jurisdictions to make sure they align with the regulations. And so it can be a little bit, if you end up with sort of a patchwork of standards and regulations, that can be a little bit complicated sometimes. But I think there's still a net positive if you're moving towards decarbonizing the transportation sector, as long as, you're being ambitious enough to sort of meet the criteria that I explained earlier, that we think it would be beneficial overall to be moving towards decarbonization, even if it's a little bit piecemeal or patchwork for the moment. The question about how does a state level CFS and a federal level CFS interact with each other if they're both present at the same time, I think there's a little bit that remains to be seen, because it will depend a little bit on how the state clean fuel standard in question is written and how a federal clean fuel standard is written, and if there's some sort of state preemption written into a federal bill or something like that, it might change the dynamics a little bit. So I'm certainly not a lawyer, and it's a little bit hard for me to say exactly what the interaction would be, but you would definitely need to sort of reconcile the two at some point. But until there is a federal CFS, it's a little bit hard to say the exact interaction.
I'd love to underscore one of the points that Rachel made around potential differences between state clean fuel standards. One of the ways to address that, I mean, some variation is actually, is good. We want states to be laboratories of democracy and explore different opportunities for optimizing this policy. But a way to pursue some level of standardization, which will help at the rest of the market work with a clean fuel standard, is to try to sort of aspire to a core set of principles. And so the key attributes of a strong clean fuel standard that Rachel ran through earlier, for us, serves as those principles. And so, when we engage with states that are thinking about doing a clean fuel standard, we're like, this is what these are some things you should be thinking about from the outset. For states that already have a clean fuel standard like California, we're advocating that they adjust their policy where needed to embrace those or to embody those principles a little bit more clearly. In California, for example, in the last round of amendments, it took one step toward doing that by setting a long-term goal with a near zero carbon intensity requirement around mid-century. It, at this point, declined to expand the scope of the low carbon fuel standard to other non-road segments of the transportation sector, but we hope it can get there.
And one more thing that I'll just add, I think you also asked maybe about coordinating between states or regionally, and whether that's helpful. I think in a lot of circumstances it could be helpful. Depending on where you are in the country, there are different things that are important or relevant for your clean fuel standard. So like I mentioned earlier, marine fuel might not be particularly relevant for a landlocked state, for example, or maybe some states have much more biofuel supply, or, so it kind of depends. And I think regional coordination can be really helpful in streamlining some of those, or maybe, mitigating some of the risks of having a different, patchwork across different states. So I do think that could be helpful in certain circumstances.
Are there reasons beyond emission reductions for a state to consider adopting an LCFS? And maybe behind the question is that emission reductions or climate isn't a motivator for all states. And so, are there reasons beyond emission reductions for considering LCFS?
Yeah, it's a great question. And the answer is yes. As I mentioned earlier, clean fuel, the metric in which clean fuel standards are built around is carbon intensity, or grams of CO2 equivalent per some unit of energy. Carbon intensity of a fuel is a decent, not perfect, but a decent proxy for the fuel's overall cleanness. And so a fuel that has low carbon intensity tends to have low concentration of other pollutants that contribute to significant health damage that's associated with vehicle emissions. And so by reducing carbon intensity, an intentional byproduct of that process is also to reduce emissions of conventional pollutants, of toxins, and we think it's a fairly efficient policy for achieving those reductions.
I'll also add, from sort of another perspective, a clean fuel standard promotes innovation and deployment and adoption of new technology. So there is also sort of an innovation angle. It is, of course, at the end of the day, still to get to emissions reductions, but it does promote innovation, new technologies, sort of diversifying the realm of possibilities for transportation fuels and vehicles and things like that.
This next question, I think Rachel, maybe to you, but defer to you if you want to pass to Jonathan. So what are the highest and best uses of synthetic fuels like hydrogen? For example, is hydrogen better used in the power sector than in the transportation sector?
So CATF's perspective is that the better uses for hydrogen are in things like industrial decarbonization and some portions of the transportation sector. So like heavy duty vehicles, and hydrogen can be a fuel for aviation and marine, but also an input or a feedstock for other kinds of aviation and marine fuels. So that's where we see hydrogen as best placed. And as Jonathan mentioned, while he was speaking earlier, there's a limited supply of biofuels, for example, and we can't have the on-road aviation and marine sectors all demanding, maximum amounts of biofuels. And so there are other types of, synthetic fuels, whether it's synthetic SAF, the definition, the exact acronym of SAF keeps changing, but sustainable aviation fuels or synthetic aviation fuels, and other marine fuels like ammonia and other things use hydrogen as a feedstock to make or upgrade those fuels. And so hydrogen is really important in the transportation sector. Even if you're not using it as a fuel, it's still going to be a feedstock for a lot of alternative fuels. And you can use hydrogen as aviation fuel, for example, but that's a little bit further off because you would have to make new, airplane designs and new types of engines and things like that. So if we wanted to use more what's often referred to as drop-in fuels, meaning, same airplane infrastructure, and you just put a different fuel in the same, tank or the same engine, it would be more like hydrogen as a feedstock for other types of SAF and things like that.
Within the past year, CATF released a pretty substantial paper talking about the highest uses of hydrogen, and with a particular eye on the electricity sector. And one of the dynamics that pointed out is that it's a pretty inefficient use or not high value use to use it in the electricity sector. And one of the reasons are dynamics like to use renewable energy to generate hydrogen to store and transport and then burn in a power plant. You might as well just use the renewable energy for electricity directly, because there's a lot of energy loss in each chain of that system. And so that's why one of the reasons why we see higher use of hydrogen in the use cases that Rachel described earlier. Okay, next question. So for states that are considering an LCFS, and Rachel, you put a slide on that include quite a few of them, what are lessons that stand out to you that they can learn from the other states that already have a clean fuel standard?
It's a good question, and I might defer to Jonathan, who's been involved in this space a lot longer than I have. But what I will say is, in our interactions with the New Mexico Environment Department folks, they are very well educated on the topic of clean fuel standards, and it seems like they've learned a lot from California and Oregon and Washington, but especially California, since it's the most, sort of active, and they were just recently going through a rulemaking and everything. And so New Mexico, for context, just enacted their clean fuel standard, and they're going through a rulemaking process right now. And it's such a complex standard regulation, whatever you want to call it. There's so many facets. Everybody has a lot of opinions on each of those facets. And so it was just interesting to hear from the New Mexico folks that they have been in close contact with the people in California who deal with their clean fuel standard and have been watching the California process really closely in each of their amendments and each of their rulemakings. And so this isn't really a direct answer to your question, but it's clear to us from our interactions with other states that they are looking at states that have existing clean fuel standards and learning a lot from them. And I think in California, especially, one of the lessons learned at a very high level that a lot of people have noticed recently is the issue I touched on a little bit of the oversupply of credits, which then suppresses the credit price. I think that was a bit of I don't know if it was an unforeseen consequence. It seems like it might have been. Maybe some people could have predicted that, but that was something that was sort of really messing up their credit market in a way that needed to be addressed like kind of rapidly. And I think that's a pretty big lesson learned that others can take from California.
I think this will be our final question. If one more comes in, we may try to squeeze it in. What coalitions exist to support states that do adopt an LCFS? I will say that the Climate Alliance is one, and the U.S. Climate Alliance is made of around 25 governors from across the country that are committed to achieving emission reductions on par with the Paris Agreement commitments. And that organization supports governors' offices specifically in a lot of different ways, including with kind of technical assistance to help them understand, whatever the policy, not just LCFSs, different design choices, policy considerations, and can connect them with peers who, like in states who have already adopted them. So really supportive organization for states that are moving forward on policies that are complicated, but to provide technical assistance and connect for peer learning. Any others come to mind to mention? Maybe if not, I'll just say in each state, what I've seen is that there are coalitions that kind of form around the policy. And so there may be national groups, but definitely in states here. And someone says the Pacific Coast Collaborative is one as well.
Right. Yeah.
Well, we're about at time here. Listen, Jonathan, Rachel, thank you for your presentations and your time. I want to thank everyone who joined today for your time and helping learn more about low carbon fuel standards and asking some really good questions. If you or anyone in your organization would like to learn more about LCFS programs, please reach out to any of the three of us. We're going to share a recording of this webinar online, and we'll email it to you in the next couple of days so that you have access to it. Feel free to forward it to your colleagues and others liberally. Again, today was our third webinar in our 2025 State Policy Webinar Series. If you're interested in learning more about clean firm power or clean electricity standards, in the email that we send you, we'll include links to those webinars as well. We are going to have our next webinar. It may be in June, but we'll schedule that soon, and you'll hear about it through email. Again, thank you all for joining. Looking forward to working together. Talk to you soon. Bye-bye.